Well, great. Well, thanks for joining us again,
Sure,
Barry.
this is great.
Yeah.
Mm-hmm.
And if my memory serves, we were just at the cusp of talking about your involvement with, going into your involvement with DARPA when we broke from our last conversation.
Right, yeah.
And I thought maybe we could, just back up a little bit and take a little bit of a running start to get back into that. And if you could tell us about, take us back to the kind of work that you were doing with TRW in the late 1980s and your association with DARPA over the years and how this opportunity to work with DARPA more directly came about.
Okay, that sounds good.
Okay.
So yeah, at TRW, I was involved in 2 generations of building a corporate software development environment. So the first one was about the first time that we had local area networks, and so we were getting people in networks together, and we actually used the Kokomo model to estimate whether we would be able to improve productivity. That the company is a conglomerate whose biggest thing outside of defense is auto parts, and they were sort of psyched by the Japanese 5th generation initiative and said, everybody in TRW has got to get more productivity, and if you have a good proposal for it, we have corporate funds to do things with it. So basically, we came up with a plan for this, and I used the Kokomo model to say, if your tools are better than this, if you've educated your people in these technologies, you ought to be able to double productivity in 10 years. And we put that forward, and my division general manager thought this was a really good idea, but he said, we've got to hook you up with an upcoming project so that we know that what you're doing is going to fit what they need. And that turned out to be really good, because in a lot of cases, I hired a couple of people, Art Peister, who had been at UC Santa Barbara, and Lolo Pinedo, who had just graduated with a PhD from UCLA. And so we had a very strong technical group of people, and they had a lot of good ideas for automated test case generation and things like that. And the project people said, what we'd really like is anytime we make a change in a document to put a little bar at the right that says this thing has been changed. This re-baselined everybody as far as what the real project's priorities were going to be and things like that. So at any rate, we built one, and it really did double productivity for that project, and did for a bunch of the future ones. And yeah, in looking at things, we found that most of the time people were producing documents and filling out forms rather than writing computer programs. And so we made sure that the secretaries would get on this. And so this improved productivity a whole lot, because the software people didn't have to retype things and the like. And we looked around for technology and forms management, and found that IBM and DEC and the like had some things that they were pretty clunky, and we felt we could build a better forms management system than they had. So we did, and we ended up with the world's best 1982 forms management system. By 1986, we still had the best 1982 forms management system, and because we were amortizing its maintenance over one company, and the computer companies were amortizing it over lots of things, so they got a lot better. So we did a second generation where we were doing much more commercial technology involved in it. So around that time, DARPA was getting interested in software engineering environments, and there was this project called Arcadia that Lee was involved in, and Dick Taylor and a number of people from UC Irvine were involved in, and we became sort of their industrial counterpart, and saying, here are some things that would be valuable to make sure that the industry people would be interested in them, and making some contributions, like Lola Pineda came up with the Project Master database and that sort of thing. So DARPA got quite interested in Arcadia, and there were various other things that I was doing that connected me with DARPA. And at that time, the director of the DARPA Information Science and Technology Office was a really outstanding mathematician named Jacob Schwartz. Mm-hmm. Unfortunately, he was somebody who wanted to put his hands on everything that was going on in the office, and sort of micromanage the program managers. And he basically had a disinclination to do things that weren't mathematically oriented. So he wanted to kill the artificial intelligence program. So when I got there, there was a proposal and a draft budget to do that, but I got some of the AI people to come and say, should DARPA really do this, and what kind of things, if we keep it going, do you think are going to make a difference? And so we got the Marvin Minskys and the Ed Feigenbaums and the like together, and they made a pretty strong case, and so I was able to sell the DARPA director in putting the money back into AI, which was probably, in the first month I was there, the most important thing I ever did. Since it just sort of took off like a rocket a few years later. And
may I ask you to speak about the context in which DARPA would become interested in, why was there the interest in the Arcadia program for these software engineering environments? What was the larger frame for that concern?
There were two.
Yeah, I can help with that because that was our project. At the time, back in the 90s, people were building all these tools, and there was this proliferation of software tools. And everybody had a tool that did something slightly different. And our rationale was just simply, a carpenter has a whole toolkit and knows which tool to use at what point in order to build a house. And a software engineer has all these tools lying around all over the place, and they all do something different. And, you ought to have a nice box for them, and the tools all belong in the right place, and people know what tool to use at what time and in what way. And we called it an environment. Other people had used that term. But we sold the idea of an environment of diverse tools, where the DARPA angle was it wasn't the tools that we were building, it was the box. It was the holder, it was the framework for integrating the tools. And DARPA bought off on that, and we had a pretty good run of 6-8 years. And we never produced something that became something that industry picked up and sold, but it was the blueprint for a lot of things that have come since. And I think DARPA liked the idea that they had built a framework within which you could build more interoperable tools. Well, Barry may disagree about what DARPA saw in it. That was what we thought we were selling.
Oh, that's basically it. And I think really doing a lot more in terms of you know, what's the architecture of one of those things going to be like, and how do you do traceability among the design tools and the requirements tools and the code tools and the test tools and things like that. So it was that was one basic thing. The other was that there were some other initiatives in software within DoD. One was called STARS, for Software Technology for Reliable or Affordable Reliable Software or Systems. And the Defense Department had decided that it needed a better programming language for doing defense software, and the ADA initiative came along, and so a program, the STARS program, sort of evolved into something that was going to be a set of environments for programming in ADA, and so the DoD needed somewhere to put that, and then they put it at DARPA, and so I had a couple of program managers, Jack Kramer and John Foreman, were sort of running STARS at various times, and so what we ended up doing was getting bids from companies that would develop 3 different environments, one oriented toward the Army, one for the Navy, and one for the Air Force, and getting people from the Army, Navy, and Air Force to be sort of the customers for this, and also saying that the companies needed to coordinate this with the other software environment things that they were doing. So IBM and UNIVAC basically had their own non-ADA environments, and we were trying to get them to at least have something where the ADA environments and their other environments were reasonably interoperable, and maybe used the same requirements languages, but went down to different programming languages when you went along. And so this was a major initiative. So the 3 winners were really IBM, which had its software environment actually in Toronto, and UNIVAC had its in Minneapolis, and the other winner was Boehm, who basically had done a strategic partnership with Digital Equipment DEC. And so we had a major management challenge of trying to make sure that these people were doing something that was good for them, but also good for the Defense Department. And we had the representatives of the services saying, oh yeah, all that's very nice, but we also need something that addresses some other kinds of propriety or security or other kinds of concerns that they hadn't been concerned about. So we had monthly meetings, and at every monthly meeting we would try to come up with, yeah, what are our plans for the next month, and everybody would agree, yeah, those plans are going to be compatible across the three environments, and so we'd all go off and do our thing, and the next month people would come back and they'd say, well, we went to the home office and we've got to back off with this, or and so one of the things that I found out was an important thing that I hadn't seen any tool support for previously, which was if you have a bunch of multiple stakeholders who have conflicting priorities and things like that, how do you get them to negotiate and converge on and evolve the requirements and the boundary conditions and the maintenance models and things like that for these. And so this is sort of leading to a jump into the future. That when I left DARPA, I wanted to do some significant research, and one of them was doing this kind of negotiation system for requirements and support technology and the like. And the underlying principle on it was that you had to come up with a win-win for all of the stakeholders, and so when I got to USC, we started building a win-win system, and after 18 months, I could bid for DARPA dollars again, because I was avoiding conflicts of interest before that. And so we did a bunch of generations of this win-win system based on really pretty primitive technology when it started, and we're now on the 6th generation, which looks more like Facebook. And so that's sort of a side effect of some of the things I was doing at DARPA.
Would you say that has been the main thrust of your research work after DARPA?
It was in the first few years after I got to USC, that was, and fundamentally we teach software by having the students, the master students, get together in teams of 6 people and get connected to a USC neighborhood client who wanted some software built for them, and so every year we would have about 20 teams of these, and we would use the win-win system of the day to address what was going on. And so we had the various lessons that we learned there. That one was that we were trying to do groupware on support systems that were oriented toward individuals. So basically, the earlier versions of Win-Win basically said, here's a screen, put your first win condition in, post it to the database of wind conditions and put your next one in, put your next one in. And so everybody was thinking about themselves as they were doing this. Later on, we got connected with a company called groupsystem.com, which had developed a really good set of collaboration tools. And when we worked with them on it, they said, yeah, anytime somebody puts a wind condition in, the next thing they should see on the screen is the related wind conditions that other people are saying. So if somebody said, yeah, we want this thing to run on all 4 platforms, it's Unix, Linux, Windows, and Apple, and people would say, well, do you have copies of those that we can use to test whether we can do this or not? And so there were a bunch of things that as people put something in and said, well, if you're going to do that, how are we going to do this? It really did converge things in a way that people would also sort of horse trade and say, well, if you want to our students would like to program this in Java, but if your system runs C++, we'll settle for doing it in C++ if you'll back off on some of these requirements that look like they would take more than 2 semesters to do. And so there's a bunch of horse trading that a system like that will help you do.
So was that the case? It wasn't, it sounds like for this, and I want to loop back to DARPA, but to follow this line of the win-win systems, it sounds like it was less a system where you were modeling all of the different interests and constraints of the various people ahead of time, but rather a system where people could, it would sort of surface all of these, all the various different interests and make people deconflict them in a way or something. Is that right?
That was it. And also we found it was important for them to prioritize things. The students really didn't know how much they could do in architecting it the first 12 weeks and building it the next 12 weeks. And so again, we had the Kokomo model that they could use to estimate how much effort it was going to take to do these. And it basically says, here's your most likely amount of effort to do this, and here's the optimistic and pessimistic versions, which were basically 25% higher or lower.
Right.
And so we would say, for what you've converged on that fits the Kokomo most likely model, take the things that fit within the pessimistic model and say this is going to be your core capability, and then the team will guarantee that it gives you this. But if it turns out that things weren't maybe were even easier, they could fill up with all the rest of the prioritized features. And we found that prioritizing was another really important thing to do, because when you went to inspections and testing, pretty much all of the research in test technology assumed that every test case was equally important. And what we found was that it wasn't. The high priority things are the things that you want to test first, and they're the things you want to inspect first, and so that way we got a lot of value, and we found that, again, you got twice as much value of defect avoidance per hour of inspections and that sort of thing. So, and you see that happening with modern technology. That Amazon puts out a new version every 11 seconds. And you say, how can they do regression tests over their millions of lines of code? And well, they prioritize things. They only regression test the things that are really important, and that way they can, there's little risk to it, but the next 11 seconds they can work on the next ones.
Well, I wanted to, if I could, going back to the time that you joined DARPA in 1989, there had already been this concentration or recognition that a process for creating software was important to DARPA. I wondered, was there sort of a project or an effort or some sort of event that everybody recognized as really underscoring the importance of software and software creation to the Defense Department? Or was it an accumulation of an experience? You know, was there, I guess what I'm struggling to ask is, was there like one big thing that was iconic about software's importance, or was it just that, or was it rather the accumulation of experience of the importance of software?
You got to talk about the CMM and Watts Humphrey. I'm not sure if that's what you want to talk about, but you know, the CMM and Watts Humphrey is, boy, DARPA had a heavy role in that, don't you think?
Yeah, well, basically, yeah, the three software-intensive programs that I inherited that had been assigned to DARPA were the STARS program that was doing the environments, the ADA program, and the Software Engineering Institute. So, so basically, yeah, one of the things that I was involved in it at TRW in 1986-87 was having TRW test out early versions of the capability maturity model on our subcontractors, and so we gave them some pretty good feedback on some things, and learned a lot from them on the things that they had. So yeah, the capability maturity model was something that was a game changer for the Defense Department, particularly for the Air Force, which was the first organization to say, if you're not level 3 in the capability maturity model, you can't bid on this program. And that got all the aerospace companies to immediately invest in just exactly what did they have to do to get to level 3. And so level 2 was basically the equivalent of blocking and tackling. You had to understand configuration management and requirements management and test management and things like that. Level 3 said you had to institutionalize these in your organization, and you had to have policies and standards and education programs and the like that, and emphasizing a few techniques like inspections and the like that were really only a tiny part of verification and validation, but the SEI liked that, and it sort of highlighted them. So yeah, it was very nice being the customer for the and the manager for the Defense Department of the SCI, because its director was a guy named Larry Druffel, who I had known for a long time, and both on campus or in technical things and non-technical things. So we both were about equal as tennis players, and so each of us had a tennis court in our backyard, and so when he was in LA we'd play tennis, and when I was in Pittsburgh we'd play tennis, and we played.
We thought that he had the better backhand.
I think so, yeah. And yeah, we played tennis in Singapore. That was a fun thing. Just all over the place. Yeah.
So was it? It sounds like there was just a growing recognition and a growing emphasis on the importance of software to all of these defense-related projects and activities and systems, and so this. Almost like this forcing function to have the entire community really adopt best practices for developing software.
Yeah.
Yeah.
And it was true within the DARPA Information Science and Technology Office as well. So basically, we had an AI program, which also included speech understanding and natural language understanding and image understanding and things like that. We had networking, which was software intensive. We had high performance computing, which the hardware was really important, but the software was pretty important as well. We had a really spectacular system called SimNet that was one of the things I got to do as the office director was to go and visit things that were being implemented on these programs, and one of them, the Army had adopted SimNet, and they had an Army base at Fort Knox, which besides having a whole bunch of gold there, it had a big building with 200 boxes. And inside the boxes were something that looked exactly like an Army tank. And it had windows that were the same size as the tank windows, and it was engineered so that it could shake, rattle, and roll like a tank and things like that. And what SimNet would do is train soldiers to become tank pilots and learn how to drive in formation, or avoid obstacles, or communicate with each other, or things like that, or determine how could they defend themselves from attacks and that sort of thing. So again, this was a challenge to networking technology, but again, a huge challenge to software technology. So just about all of the programs, we had some programs that were really generically addressing key software approaches. One of the program managers, Bill Shirless, and I said, yeah, we've got to stop building software one instruction at a time. We really ought to do it one component at a time, and one attractive way to do this was to do it within particular domains, and so we had a program that was saying, let's try to build components for command and control systems, for ground vehicles, for air vehicles, and things like that. And as I remember, yeah, Dick Taylor got one of these that took some of the Arcadia technology and used it in a command and control environment, and so and try to come up with components that would interoperate and so you could compose different kinds of command and control systems for different purposes using these components and tailoring them. So we had that. Yeah, another thing that Bill Shirless and another DARPA guy named Steve Squires got involved in was this was about the first time that the internet got hacked, and people said we've got to come up with some way to build technology that avoids this and build practices and a place where people could go to get help on hardening their systems. And so Bill Shirless and Steve Squires said, yeah, we ought to get the SEI to do this. And the SEI said, yeah, we will create something called the Computer Emergency Response Team, or CERT. And it is still the biggest security organization in the U.S. government.
I was at DARPA visiting that day that worm got let loose on the internet.
Oh, really?
Yeah, we had been, the Arcadia Project had been hauled into D.C. to stand and deliver and to do a major presentation to Shirless and Squires, and I think Jack Schwartz was there too. So, you know, we spent weeks preparing and doing our slides and everything, and we had it all planned out, and we showed up, and we got about 2 or 3 slides into it, and suddenly people started jumping up and running out of the room and buzzing back and forth, and other people came running in and running out, and like, what in the world is going on? You know, we got this presentation here, and finally at one point they said, you guys are just going to have to go home. And then on the plane on the way home, we heard about the infamous internet worm that ate DARPA. It was quite an amazing day to be there.
I guess, right.
And it had obviously had a lasting impact.
Yeah.
Do you remember? Was that occurred while you were there also, Barry?
No, that was when Jack Schwartz was running the office. So that was 88 that the
right
worm
beforehand.
Yeah, right. Yeah.
Yeah, just luck that I happened to be there.
Yeah.
So David, did you wind up interviewing Watts Humphrey before he passed away about the CMM?
No, I don't believe that we have.
Well, that's an interesting story. If you and I are together this spring, maybe I could tell you something about the CMM, because I was on Watts's advisory board at IBM, and then when he went to the SEI, he invited me to come and be on his advisory board there. And Bob Balzer and I were members of that advisory board right from the beginning all the way up through the mid-90s, and could tell you a lot about the CMM and where it came from and how it evolved. And in fact, the reactions to the CMM in the form of things like agile methods and those kinds of things were probably as significant as the CMM itself. But, you know, Barry was there while this was going on at DARPA, but I still remember a conversation. Watts Humphrey was just this amazing dynamo of a man, and some of what he wanted to do with the CMM seemed to most of us to be kind of wrongheaded. So you probably maybe never met Bob Balzer, and you and I haven't gotten to know each other very well, and it sounds like you haven't met Larry Druffel. But between the 4 of us, that would be Barry, Larry, Bob Balzer, and me. I think, you know, 4 forces of nature, and we could not budge Watts Humphrey 1 inch. He just did what it was he had in mind. And some of it was good, and a lot of it was unfortunate. But it had an amazingly formative effect on software development. How people feel about process to this day, strongly influenced by what Watts Humphrey felt was the way it should be done. I don't know if you want to go into it any further than that, Barry, but a lot of it happened on your watch.
It did start having strains, and it also had successes in that fundamentally the system engineers were pretty chaotic, and they said we need a system engineering capability maturity model. And so 2 of those got started with different system engineering oriented societies, and they were not all that compatible with the software ones. And so one of the things that I was just rotating out when they started to converge the software maturity model and the system engineering maturity model, which became the capability maturity model integrated, and displaced the 2 that were sort of confusing the situation. So, but yeah, originally they were really oriented toward this waterfall model that basically says software is just as easy as having water trickle down a waterfall. You start with requirements, you go to preliminary design, detailed design, code, test, integration, and acceptance, and yeah, people found that this used to work for heavily scientific kind of programs, which was what TRW was doing in the 70s was primarily things that were keeping track of satellites and keeping track of the information that the satellites were doing and the like, and it was all batch processing kind of things. All of a sudden things became interactive processing, and you really needed to do a lot of prototyping to do this, and you couldn't say we are going to organize the screen like this and have that propagate through and deliver something that the commanders couldn't use, and so a lot of things said, yeah, you've got to do a bunch of system understanding and risk reduction and operational concept formulation and things like that before you start going into actually building stuff. So this was actually a good thing because the system engineers were more cognizant of that situation, and a good example was that the first capability that you were supposed to worry about was requirements management, and the first sentence in the CMM's description of requirements management was requirements management and requirements definition is not the job of the software engineer, but a prerequisite for their work. So at TRW, that tended to be the case when people were creating a new satellite system, that the propulsion people and the structures people and the guidance and control people and the communications people would sit around the center table with their architectures and define what the system was going to be like, the software people sat around the periphery of the room waiting for somebody to give them some requirements. But after a while, the software was really driving the systems. In 1960, 8% of the functionality of an airplane was being driven by software. By 2000, it was 80%. So if you're going to lock the software people out of the room or put them at the end of the outside the table, things aren't going to go so well. So
the software is not going to work, and the plane isn't going to fly right, and the software people are going to get blamed for it. So I worked at Boehm in the late 70s, and I can see this. It started out with the mechanical engineers laying out the frame, and then you wound up with the propulsion people, and after a while you had the electrical engineers stringing some wires, and then when they got done with all of their boxes and pieces of sheet metal, they'd turn it over to the software engineers, and they'd say, "You guys need to make it fly." And the software engineers would go, "Now?" You've messed it all up. And then everybody would point fingers at the software people and said, "Well, we did our jobs, and these software people, they're helpless, they're hopeless. Plane doesn't fly, it's their fault." Everybody else had left the room by that time. It's clear that that was not going to last very long.
When did that sort of model change?
Well, there were various things that changed it. One was something that just as we had one of the things that I did in the mid-70s was to lead an activity for TRW to have policies and standards. So at the time, all the things that we had done well in the 60s and 70s in doing these high-tech kind of things, so the waterfall model was good, and it was all batch processing. There was no user interaction or anything like that. And so we said we have the most effective way of building software that there is, and there was a really outstanding engineer named Winston Royce who in 1970 wrote a definitive paper for an electronics conference that described the waterfall model, but it did say that you really want to do some building it twice so that you know roughly the directions you want to go. But basically our corporate publicity said, yeah, you should come to us for software because we're the masters of the waterfall model. And then when the prototyping stuff started coming along, Win Royce and I would have a bunch of conversations about, you know, what are we going to do about this, and basically looking at statistical decision theory, that you can say that prototyping is a form of risk reduction, and that you ought to have some risk reduction kind of things going on. And so, and rather than doing a sequence of specifications, you ought to be doing a combination of specifications and prototypes, and a way to sort of look at this was to say that you were not going step by step, but you were going around a bunch of spiral circles. And so in a couple of, I can't remember, were you in the early process workshops?
Yes.
So
I missed the first one, but I was.
Yeah, so
the rest of them.
the first one was in England with Manny Lehman, and yeah.
I missed that one.
Yeah, right, yeah. But we hosted the second one in California, and I presented this spiral model, and various people said, hey, that looks like it's got some better characteristics than the waterfall. And it started taking off for things that were more risk reduction kind of steps. And even that, though, I think was a little bit too heavyweight, and well, it was good for big defense systems, but it was it was heavyweight for business systems and the like. And so in the mid-90s, you started seeing people doing agile methods and saying that, yeah, what you ought to do is just interact with your customer, find out what they want, and build them an initial prototype. And what they don't like about the prototype, you do another sprint and fix that and say, now what do you want? And so agile methods became a very popular thing to do, and so there were some big battles between the agilists and the waterfall people, who thought they had solved the problem by calling something a V model. It said, you go down this way and you go requirements, design, code, and then you get to the bottom and you do code, and then you test against the design and you test against the requirements. It's just the waterfall tipped over. Mm-hmm. And but the maturity model was reluctant to change and determine when to do the waterfall and when to do agile. And one of
I think the truth is, in my contacts with Watts, he always claimed that the CMM was only about determining predictability. He was not particularly interested in how you build software, just whether your projections about cost and budget, scheduling and budget, could be trusted or not. And his claim was, his motivation for the CMM was just so that the Defense Department knew which of those line contractors could be believed and which ones could not be believed. And if you got to level 3, then you probably could make predictable, believable predictions. And at that point, you're okay with Watts. And as to actually how you built the software, he really, it was really hard to see it at first, but he backed away from that, sort of like, not my business. But in order for him to make his determination of whether you were level 1, 2, 3, 4, 5, you had to fill out these enormous amounts of paperwork, because he looked at these documents that you produced and decided whether they indicated that you were trustworthy with this, that, or the other characteristic. And it was that paperwork that people resented. And it was at that point that the Agile Methods community popped up and said, all of this paperwork is for the birds. The only thing people really care about is the running code. So what you should do is write the code first and get to the paperwork later on. And, Watts actually, as far as I could recall, never really felt that that was a bad thing, except that it led to lack of predictability. So he was pretty much agnostic about whether people used agile methods or other kinds of methods, as long as they were predictable. But that whole extreme programming and agile methods community sprang up as a response to Watts and his pushing for all of the paperwork it took to document what level you were supposed to be at.
Yeah, a classic example of that was a picture that Lockheed Martin made of one of their really big projects, CMMI Level 4 Memorial Library, which was a stack of shelves about as big as this conference room wall, and they were all spiral binders of results of each code inspection and things like that, so that the SEI also did training courses and licensed people to be auditors or lead auditors for. So if you wanted to be level 3, you had to bring a team in that would audit this library and say, yes, you're level 3 or you're level 4 or whatever. Yeah, the Agile people made fun of all this, and I remember one other interesting parody of a call for papers for a conference that was called Waterfall 2006, and it was going to be held in Niagara Falls, and it was Agile people are not invited. There was really quite a battle between the Agilists and the Waterfall CMMI people, and the SEI just really had a hard time figuring out, what was the equivalent of level 3 if you were doing Agile and the like, and so they were really behind the times even by 2006, sort of hanging into the waterfall.
Has that, just following that line out, has that resolved to this day?
I think what has been resolved is that there are combinations of Agile things that you want to do and plan-driven things that you want to do. So another book that I ended up co-authoring with a guy named Rich Turner was something called Balancing Agility and Discipline. And it basically said, that there are things where lockstep discipline is not a very good thing to do, but there are places where coordinating what you're doing is a very good thing to do. And showing some examples of where the Agile manifesto, they had a manifesto that basically said things like embracing change rather than following a plan. And this turns out to be a good thing in some cases, but not a good thing in other cases. At one point at TRW, I was on a panel that was saying, what were the causes of so many missiles getting launched from Vandenberg and then blowing up because of the software? And in most cases, it was because people were responding to change over following a plan. They'd say, we've got this fix that we've got to do, or we've got this telemetry station that's moved, and we've got to put a patch in the software. And there's not enough time to do the regression testing and the configuration management and following the plan. And so launch the rocket, and boom, there it goes. So responding to change over following a plan may not be good in some situations. So
David, I guess what I would say is that things have sorted out roughly as follows. If you have a website or a web service or a browser or something like that that you want to get up pretty quickly, that the community tends to understand that you would use an Agile method. And you would get this thing up, and it would, work pretty well, but probably would need to be adapted and adjusted and debugged and so on. And people understand about that. So you use Agile methods to bring it up real quick, and then use Agile methods to make it better and better and better. And what Watts Humphrey would say is sort of like, well, I don't see a whole lot of predictability there, because to borrow on Barry's example, sometimes the rocket blows up and sometimes it doesn't, and I want to be more predictable than that. And I think that that's quite correct. And in fact, for things that really matter, if your whole bank is going to rest on this, or your entire business has got a stand or fall depending on whether this thing works correctly or not, people don't tend to use agile methods. They may claim that they do, but they sort of, in an agile way, move down the waterfall in some sense, or around the spiral.
Right.
So, I think when things are important, people really do fall back on plans, and they want to know what they have, and they want to be sure they can trust it. And that's a more ponderous but reliable way of doing things. But most of the work of the world is done with these agile methods, where something gets brought up, version 1 is not going to be very reliable, or it's not going to be very fast, but the next version will be better, and the world goes along with that. And from my point of view, much of the problems that the world has is in thinking that more software will fit into this second mold of agile development without causing problems than is really the case. So now you have important things that are brought up with agile methods in a rather slapdash way, and now you have big failures. But I think it's resolved into a judgment which is made sometimes incorrectly about whether to use agile methods, whether it's safe to use agile methods, or whether you really have to do the more ponderous and reliable thing.
I wonder how issues of computer security may change that balance.
Basically, what the agile people say all you need is user stories that say, as the manager, I need a way of seeing an exception report if anything gets more than 10% behind schedule, or I need a trend analysis that does this. And people will start building things that satisfy those stories. Unfortunately, the agilists treat security as a story and say, we want our system to be secure. Well, we won't know what that means until we build some stuff. So let's put security into release 6, and so by the time you've released 1, 2, 3, 4, and 5, you've built some unsecurable software. And so people have come to recognize that you don't want to get into that trap.
I wanted to loop back to your story about rescuing the AI budget at DARPA. Did you come in with a predisposition toward the value of artificial intelligence work, or did that seem like such a big shift that you really wanted to? The defunding seemed like such a big shift that you really wanted to take another look at that, or had you had some prior experience with AI that shaped your thinking, or?
Fundamentally, one of the advantages of the RAND Corporation was that during the summers they would bring professors in to complement the RAND staff in looking at new things. And so in the 60s, there were several summers where Alan Newell and Herb Simon would come to the RAND Corporation and really do pioneering work in AI. And one of Simon's grad students was Ed Feigenbaum, and so he and I were about the same age, and we're sort of buddies, and still are. And so I had a good appreciation, but another of my roommates at that time was Stuart Dreyfus, who was the brother of Hubert Dreyfus, who wrote the book What Computers Can't Do, and showed all of the failed predictions that say in 1958, in 10 years, the computer will be the world's chess champion. Well, they got there, but not in 10 years. So I was getting sort of a balance of skepticism and enthusiasm, but in one case, I was going from being just a programmer to being I ran something called the Computer Systems Analysis organization at RAND, and one of the things that we wanted to make sure we did with the system analyses was to apply them to various challenges. One of them was the Minuteman command and control system. That basically you had these missiles that were in bunches in Montana and North Dakota and various places, and people were worried about the fact that if you if the Russians targeted their missiles the right way, they could disrupt the communication system so that the Minutemen wouldn't be able to launch. And about that time, I think I mentioned the last time that my wife Charla worked with Paul Barron on distributed computing, and I ended up doing a simulation of how that might work in a Minuteman command and control system, and finding that you needed a learning algorithm to determine, if you had a system where parts of the system were going down, you needed some way to reroute things that weren't the shortest path until one of the nodes on the shortest path disappeared. And
right.
So I was doing this in concert with the people at UCLA, Len Kleinrock and the like, and came up with this learning algorithm that said that if a message comes in, it says, I came from node 10 and I got here via node 14, and I got to your node 16 and I need to go to node 22, and it took me, I got here from there in 3 hops, and it's going to take me 2 hops. So that's really information that's useful. If you get something that's going the other way, you can say, yeah, the best way that we know to get from there to node 4 was going out on node 10 and that sort of thing. So I interacted with the AI people to see what are the best ways for the system to learn about that kind of thing. And so it was an appreciation that, yeah, could be used for nice practical systems, and they had good algorithms for learning that kind of thing.
And it seems like an interesting time when the move was being made at DARPA to defund the artificial intelligence research, because this is, if my memory serves, this is the beginnings of the so-called AI winter, right?
Yeah.
Where the kind of like the great expectations for expert systems and that whole sort of enthusiasm around that was starting to abruptly shift or something. Was that part of it? Were people?
Yeah, that was
that part of it.
A big thing that some of the people that Lee and I were mentioning, like Bob Balzer, were victims of the AI winter. That Ed Feigenbaum had founded this company called Technology that basically said another thing that made it popular and profitable early was the Japanese fifth generation initiative, where basically Ed Feigenbaum and another woman wrote a book that basically said the Japanese are going to blow us out of the water because they're going to harness AI and then we're going to be way behind. And technology was a bunch of smart AI people who could go to a company and say, here's some things you might do. And so yeah, Bob left ISI and went to technology, and things went really well for a while, and then basically the Japanese fifth generation thing sort of petered out, and the AI things really didn't cover the complexities of some of the things that the companies needed, and so on. So yeah, there was this AI winter.
So David, in fact, there have been a number of AI winters. There's been at least 2 or 3 distinct AI winters.
Yes.
And
So I've learned.
These are very, very smart people, and they're expert marketeers, and they always overpromise. So, you know, when I became a manager long, long ago for the first time, my boss said, your job as a manager is to manage expectations. You never let people's expectations get out of the box, because if they get out of the box, you can never win. If you do those incredible things, people will say, well, sure, but most likely you're not going to be able to do those things, and people are going to get mad. So, you know, the AI people have always made the mistake of overpromising. So yes, there were people who said in 1955, pretty soon a computer is going to be the world's best chess player. Computers are going to automatically translate any language into any other language faster than anybody can even think the words. And all this crazy stuff. And, you know, it's just inevitable at some point that these promises are not going to be met. And then there is a backlash and there is an AI winter. So right now, AI is riding, you know, very, very high, and you hear AI people making the same kinds of irresponsible promises, and some of them will be met, and a lot of them won't. And my own personal belief is that just as every AI boom is bigger than the previous one, every AI bust will be bigger than the previous one too. So I'm about to write an op-ed piece that I'm going to send somewhere called, in parens, another AI, winter is coming, because they're doing it again.
What's your perspective on that, Barry?
Well, it's sort of similar with agile methods. These things are really good for some things, but they have their soft spots. For example, you can spoof an AI learning system. That you know, people have found that. I think the first one was the AI system that did checkers, and basically, if the way you beat it was to make really bad moves, and anything it did caused them to win the match, and so you'd play 10 matches, and then they'd say, well, let's raise the stakes and play one more. And the AI thing would capitalize or make bad moves that were being rewarded and lose the match. And so this kind of thing could happen applying AI to security and that sort of thing. So.
But nevertheless, you know, in that 1989 iteration of the kind of troubles with artificial intelligence research and activity, you decided that, you know, that to continue the course, you know, despite the downward pressure, if you will.
Yeah, so fortunately, while I was there, there were some big wins for AI. So one of my program managers was he was a Air Force major when when I got there, and he got promoted to lieutenant colonel, but he introduced himself to saying, "I am the major cross that you're going to have to bear." And he's now the #2 guy at Georgia Tech, and he was the director of the Software Engineering Institute and had a really outstanding career. And he got some CMU and MIT people to come up with an AI constraint-based planning approach to solve transportation problems. And this was in 1990-91, and they came up with a system that could do in 4 hours using constraint-based planning what it was taking the clunky transportation commands software 4 days to do. And just about in 1991, we needed to get 500,000 people off to the Middle East to fight the first Iraq War, and the transportation command said, "We're confiscating your Sun your Sun computers because we need your system to plan all of these things." And wow. And they replaced them eventually, but fundamentally this was a key to getting all that stuff there really fast, and a triumph for AI, and Steve Koss got the Golden Nugget Award from the Commander of the Air Force, and went on from there, and so. There were enough examples like that you could make a case that AI was something that was really going to help.
It is the world chess champion and the world Go champion.
Yeah, right.
Yeah, absolutely. Well, maybe we could talk just a little bit about what is behind this report that you brought to the interview, Barry, about which sounded like a major effort of yours while you were at DARPA.
Yeah. So one thing that we had really was a community of software research people. That some of them were sponsored by DARPA, some by the Army, Navy, and Air Force Offices of Scientific Research, and what I was finding was that things were underfunded, and the professors didn't have enough funds to really make critical masses of grad students to scale up their approaches, so what I proposed, and my DARPA director said, we don't usually do things this way, but if you want to convene all of these various offices of scientific research and potential consumers of the technology and the like, and come up with a strategic plan for how to make software get a great leap forward, basically. And so this rather thick thing went through all of the various technologies that were involved, including process technology and requirements technology and test technology and associated things that would apply AI and other kind of things to them, and coming up with a thing that said, if you here's the first 10 years of the plan, and here's what we would expect as milestones and things like that, And here's a cost model that basically says, yeah, if you can speed up the process of getting from requirements to design to code to test and the like. Here's what the savings are going to be, and here's what the cost of the program is going to be, and then you've got a very large return on investment. And people more or less bought the business case, and so we had this big event where we showcased this and then got everybody excited about it, and then my boss got promoted from being the DARPA director to being the director of Defense Research and Engineering, and he said, "Yeah, well, let's float this and see if it flies." And unfortunately, what I found was that a lot of organizations didn't want money added to their budget that they didn't control. So I had this two-star admiral who was the head of the Office of Naval Research, and he said, I get my money from the Chief of Naval Operations, and I follow his priorities. And our big priority right now is corrosion. Our boats are getting corroded, and we need more research in corrosion technology and software. I can't really accept your software money. It's if I get more money, I'm going to use it for corrosion. And so again, you found all sorts of things in political Washington that complicated selling something that looked good for what you were trying to do, but not necessarily for what other people were trying to do. So.
Right.
Who were higher ranked than you were.
So Barry, I think you're being modest. Basically, as usual, we're ahead of your time. I think it was a time when people had not quite focused on software as being the core problem that everybody had that required a direct focus. And David Barry is one of those guys who went to Washington and he had his head screwed on tight and he knew what was needed. And he focused in pretty nicely on the importance of software and computer technology and so on. And what happened is exactly what Barry described, is everybody said, oh, it's my problem too, it's my problem too. And everybody said, okay, then I'm just going to focus on it in my way. And instead of it becoming the focal point that Barry correctly saw it needed to be, it just got divided up into tiny little pieces. And I mean, at this point, there is this recognition, and there is starting to be that kind of focus, but Barry's just ahead of his time, as usual.
So so your plan was never fully implemented?
Yeah, well, it didn't pass initially. Toward the end of my, this was late '91, and I was going to disappear somewhere in, it was September '92 when I left.
Right.
And as I was exiting, my boss was redoing the budget, which basically with the Berlin Wall falling and various things like that, a bunch of money that was being targeted for doing various kind of things with our ICBMs didn't need as much money as people were bidding for, and he said, here's $40 million and $40 million a year, and see what you can do to get this off and running. Unfortunately, I only had 3 months to get it off and running, and the people down in the middle of the Office of Naval Research couldn't outvote their admiral in terms of submitting a plan for doing this, and the admiral saying, "You're just complicating my life. I'm just going to use my Navy budget." And, so it looked like it was going to be a winner for a while, but it didn't make it. Yeah.
Do you feel that the sort of needs that you had identified, the fundamental needs that this plan was designed to address, do they still exist today? Would an updated version of this sort of plan
I think
be needed?
One is needed, and I think it gets needed in getting companies or the Defense Department to build things more like what the really advanced software companies like Amazon are doing. So Amazon comes out with a new release of their software every 11 seconds, and there's this approach called Devops that fundamentally says that you organize your system in a way that many things can be going on in parallel. Many things can be integrated in parallel. Many things can be prioritized in terms of regression testing and the like, so that the most important things that are going to need to be in there in the next 11 seconds are going to be there, and then the flexible plan for what's going to happen in the next 11 seconds and in the next hour, and then things like that are being worked on. And there is a movement in Europe to address this. I don't know, Lee, have you looked at any of our Circ Talks webinars? Okay.
Barry, I think basically what happened right around the time you're leaving DARPA was that the private sector came rushing by the government.
Yeah.
In the 60s, the 70s, and the 80s, the government, in particular the Defense Department, was the big dog in software. Basically, the Defense Department had all the big problems and spent all the big money and pioneered an awful lot of innovations and so on. And way back in the rearview mirror, you could see the private sector, and suddenly around 1992, 3, 4, 5, they came whooshing by, at light speed. And suddenly they had way more money to spend than the federal government did. And somewhere by the year 2000, they had really taken the lead. And their agenda became the community's agenda. And their agenda was all about getting things on the internet and getting things to market and getting things fast. And Barry's agenda, which said, hey, it's important these things work. It's important to have characteristics that we understand and that we are assured of before the thing gets deployed. All that stuff just got lost in the dust of Google and Microsoft and Amazon rushing by, putting stuff out there and spending really orders of magnitude more than the federal government could. And, and then eventually the federal government, turned around with its nose pressed to the window and said, hey, could we have that stuff too? and a lot of bad things comes out of that. You have the Microsoft operating system that's built inside of lots of things that the Defense Department deploys that NASA puts out in space, and it's just the cheapest, easiest way is to sort of like, well, let's just put the Microsoft operating system on and load a couple of applications on top of that. And now you've got all of that dead weight of this operating system, which at this point, at least, it mostly works. But it's... Anyway,
it used to be the blue screen of death, but you would find that.
Barry tried to do the right thing, but Washington is a very tough place. And then I think a lot of it got overtaken by events, and the events mostly were, the rise of this huge industry with, in unbelievable amounts of money to spend.
Yeah, I think another milestone in that was Michael Cusimano and Rick Selby writing that Microsoft Secrets book that basically said, yeah, you want to carry multiple things along and pick and choose which ones are going to survive and that sort of thing. And unfortunately, they had this backward compatibility challenge, which really made things worse as things went along, because they had to keep everything compatible with 3.1, 7.2, and Vista and all that kind of thing.
Right.
Yeah.
To going back to your comment about Amazon and updating the system every 11 seconds, is that literally that updates every 11 seconds?
Mm-hmm.
Is there a particular person or a particular group of people who are associated with this DevOps sort of technology?
Yeah, there's a guy named Dean Leffingwell who built something called SAFE for structured agile something. And it's proving to be pretty popular. There's this fellow at Chalmers University in Sweden, Jan Bosch, who has made a success of doing this kind of thing, and has got a consortium of big European manufacturing companies like BMW and Volkswagen and Saab and Volvo and Ericsson and the like. And they are finding that what Amazon can do for software-intensive things, they can probably do for cars. So that I don't think every 11 seconds they're going to beam something into your car's computer, but there is this idea that you're going to get continuous updates of your car rather than bringing it in for service every 5,000 miles or whatever.
But I think the point is that there isn't a person that's involved that's making this decision every 11 seconds. It's software, and I guess it's not unfair, Barry, to say it's AI. So there's some AI kind of software that's making this decision and deciding when it's safe and when it isn't, and how to put it in and when not to, and when to pull it out.
Mm-hmm.
Interesting. Well, maybe in the time we have remaining, I would be interested in your reflections on two different things. One is about your decision to teach after your stint at DARPA. What was and what you have found to be the most rewarding dimensions of that of your career at USC, and so I'd be interested to hear you talk about that, and also then just to your perspective on I guess, what has been consistent and what has changed in just the whole world of software, and where you see that balance of continuity and change heading in the future.
Okay, sure.
Yeah.
Okay, well, in terms of, let's see, what was...
One was about coming to USC, yeah.
Okay, yeah. So at one point, I was asked by Simon Ramo, who was the R in TRW, to help the company recruit more really bright software people, because that was really a limiting feature on many of the things that the company was trying to do. And so he asked me to go and try to come up with a program where TRW would hire some really bright people and give them 2 days a week to go to either USC or UCLA to get a master's degree, and this would be a plum thing that really smart people would do, and so basically I went around to the people at UCLA and USC, and surprisingly they wanted to do it. And for one, they were having a hard time hiring U.S. citizens, and for another, Simon Ramos said, yeah, if you're willing to do this, I'm willing to give your department chair a nice big annual gift. And so we came up with an initial set of things that would be part of the program, and Simon Ramos said, yeah, you don't want to we don't want to get super programmers out of this. What I've found that in our company, the most valuable people we have are T-shaped people. They're very deep in whatever their specialty is. Maybe it's astrodynamics, maybe it's electronics, maybe it's communications, maybe it's software. But the ones that are really helpful are the ones that know a little bit more about the other parts of it, about the management and the economics and all the other things. And this was basically true of most of the new hires that we would get as software engineers at TRW. It would take a year to get them to appreciate and understand what configuration management was all about, what requirements engineering was all about, what how do you estimate costs of things and the like. And so when I was 55 and saying, yeah, I'm going to early retire or stay here for another 10 years and get excused at 65, I think what I'd like to do is go to either UCLA or USC and take these I-shaped bachelor's students in computer science and make T-shaped people out of them. And the software projects were a good example of that, because they had to learn, the requirements are things you negotiate. They aren't things that you just write up and follow. And estimating the cost is going to be critical to whether you can do it in 12 weeks in the fall and 12 weeks in the spring. And so basically we put together not just the project course, but a master's in software engineering that meant that the core courses were not just architecture and things like that, but they were courses in human-computer interaction and management and economics and things like that. So, so this turned out to be worked out pretty well because particularly when the students showed up for job interviews, basically they knew what configuration management was all about. They had a portfolio. They could show you the project that they did and how they used all these various techniques and the like. And we got a lot of more companies to come to the job fair and in particular look for the students that were going through this program and seeing if they could hire some of them. So,
right.
Yeah, that was put off for 3 years by this surprise offer to be the DARPA office director. And so in '89 I left DRW, and in '92 I came to USC. Which,
right.
So that was sort of the main thing that I decided I wanted to do here, and again, doing the project courses meant that you had a critical mass of data that you could use to test out hypotheses that said prioritizing the inspections and the tests will give you a payoff and the like. And so we've had 15 PhD students who have used the project courses as places where they can, and say that this is not just a good idea, we've got data that show that it works, that sort of thing. So, and so it's been a very nice combination of education and research that comes out of this.
Right.
Yeah, that was item one.
The other item was just, you know, from your career's length association with the world of software, I was interested to hear your reflections on, you know, what fundamentals do you see as being consistent across that time with respect to the nature of software and the nature of making software, and what have been fundamental changes, and where do you see those going? You know, what seems sort of intrinsic and what seems to change?
Well, I think the main thing is that change is going to be constant, and we tell our students that we're going to try to educate you to have a successful career out into the 2050s. We have no idea what it's going to be like there, but and we give assignments that say we want you to not just learn, we want you to learn how to learn. And so the assignments in the software management economics course say you are the CTO of a 500-person software company, and your chief executive officer is concerned about AI or DevOps or artificial intelligence of various kinds and the like. And what you need to do is to give him an analysis of how mature are these, and what are their strengths and what are their weaknesses, and what would we have to do to address these. And that you're going to get graded on how incisive your analysis is, plus the number of different ways that you learned about things. So you can't just go to Google and stop there. That, you should try to interview some people that are in companies or are developing this kind of research and things like that. You should look at the proceedings of conferences and the ACM and IEEE literature, and so the more sources you do, the better your grade is going to be. And so we're trying to get them to learn how to learn, and that kind of thing. And we've found that, yeah, we have to learn how to learn in running the course. So in 1995, when we did our first set of project courses, basically the students had to program their own web crawlers and search engines and things like that. In 5 years, basically there were COTS products that did these, and so every year we would find we'd spend our summer reinventing the course, and yeah, between 2000 and 2010, things went from being COTS intensive to cloud services intensive and web intensive and things like that. So again, it's continuous learning for the instructors as well as the students.
Right. I guess the last question that we have time for is, you know, earlier in our discussion today, we talked about the functionality of an aircraft, from going from 8% that software was responsible for to whatever it is, 80% or higher today.
The F-35 is saying 90%.
Yeah, okay, 8% to 90%. It also seems that, you know, from just all of the kind of systems and services of our society, the role of software has gone from 8% to 90%,
yeah,
or you know. And do you see that? Is that trend just going to continue, or what do you see? What do you see as you look out ahead?
Well, that was, yeah, Lee. I sent you the ICSI 21 thing the biggest conference in software engineering is the International Conference on Software Engineering, and it asked Lee and me and various other people to comment on the previous ones of these and what were the highlights and the like. And so I ran the one in 1999, and the theme was preparing for the software century. And here, 18 years later, who are the top 5 companies in the world in terms of market value? And they're Amazon, Microsoft, Google Alphabet, Facebook, and one Chinese company, Tencent. So again, the software century is already upon us, and you know, where it goes from here is going to be a continuous learning kind of thing. I really don't believe that there's going to be a convergence in 2047 when the computers take over the people and the like, but there are people who actually believe that. So again, I think learning how to learn and keeping your mind open to new things coming along. That it's amazing how many things you don't need anymore.
Well, thank you very much. I think we'll need to break here, but I've just enjoyed it very much. So thank you.
Oh, I
once
enjoyed it
again.
very much.
Yes.
Thanks, Lee, for all your
Thank you so much,
yeah,
Lee.
yeah.
Thanks for inviting me in. I really enjoyed it.